What's it like inside a massive galaxy cluster? Most galaxies really aren't isolated in the vastness of space, but are gravitationally bound to one or perhaps more galaxies. Therefore, numerous galaxies can be held together by the very same force which holds humanity to the Earth. Groups can be modest, including such two galaxies circling one another, or vast, like the rich Coma cluster, which spans over 10 million light-years and contains many galaxies. Hello everyone, welcome back to the Tech Universe. One can only imagine what it would be like inside one such massive galaxy. So in this video we will be talking about what it is precisely like inside a massive galaxy cluster. But before that, hit the subscribe button and turn on the notifications to get new updates about space and tech. Also, don't forget to hit the like button. Discovery of a massive galaxy. A multinational group of astronomers claims the discovery of a set of entities that seem to be developing a collection of galaxies in the formation, termed as protocluster, is a publication issued in the Astronomy and Astrophysics journal. Brenda Fry, who is an associate professor of astronomy at the University of Arizona's Stewart Observatory, as well as a co-author of the study, said, "This discovery is an essential step forward into our eventual aim of trying to understand the assembly of galaxy clusters, one of most humongous structures which occur in the universe. For example, the Milky Way, where our solar system is located, is a component of the local group galaxy cluster, which is, in turn, a component of the Virgo supercluster. However, how did a supercluster like Virgo look like 11 billion years ago? We know little to nothing about protoclusters," Fry explained, particularly because they seem to be so weak, too faint to be seen by optical light. At about the same time, they are also known to emit intensely in other wavelengths, including the submillimeter, says the researcher. The protocluster studied in this study was discovered during an all-sky scan conducted by the European Space Agency's Planck Observatory. It was the most visible in the far-infrared spectrum of electromagnetic energy, while shifting through a library of more than 2,000 forms that could be on their path towards becoming clusters. Researchers identified petahertz G237.01 plus 42.50, or G237, a protocluster named as petahertz G237.01 plus 42.50, or G237. The discoveries were promising, but more research with other telescopes was required to confirm its identity. The team utilized the total strength of the Large Binocular Telescope in Arizona, which would be operated by Arizona, as well as the Subaru Telescope in Japan, headed by Mari Poletta of the National Institute of Astrophysics in Milan, Italy. The G237 protocluster comprises 63 galaxies, as per the researchers. The first observation and the follow-up discoveries were made combining archival data, the Herschel Space Observatory, and the Spitzer Space Telescope. You may think of galaxy protoclusters like G237 as a galaxy shipyard, where enormous galaxies are indeed being made. Fry said, adding that this structure was present when the cosmos was 3 billion years old. Simultaneously, the genealogy could be nearer than people realize. We believe the Milky Way might well have docked at a protocluster node comparable to G237, as it was very young, since the cosmos is homogeneous as well as the same in every direction. G237 observations initially revealed a very high total star-forming rate, and experts struggled to derive meaning of the data. The G237 protocluster seemed to be 10,000 times considerably faster than the Milky Way at producing stars. The protocluster's star fuel would have been quickly drained at that rate, and that would have eventually settled down into something comparable to the Virgo supercluster. Every one of the 63 galaxies seen in G237 was like a high-altitude star factory. Fry said, "It's as if the cosmos were working overtime to put the stars together, but unfortunately the output rate could not be maintained. At this rate, the supply links are expected to fail in the near future, effectively closing down the galaxy shipyard. To achieve such high yields, continuous infusions of fuel, which in the instance of stars is hydrogen gas, are required. This, as per Fry, would require a well-connected supply line sucking in absurdly large amounts of fresh gas to fuel the star-forming factories. Moreover," she added, "we have really no clue where all that gas originated from." Despite this, Paoletta claims that the total star-forming rate steadily increased, at least 1,000 solar masses per year, even after the unnecessary data was removed. But the Milky Way creates around 1 solar mass per year. The image we have is just of a successful galaxy shipyard that is operating at highly efficient rates to assemble galaxies as well as the stars inside them, and has a much more sustainable supply of energy," Fry said. Each galaxy in the cosmos is linked by the cosmic web, which is like a massive structure that looks like a three-dimensional spiderweb. The nodes which correspond to the galaxy shipyards can be said to be an analogy, are where the strands of the cosmic web converge. We believe the filaments mediate the passage of hydrogen gas from intergalactic space's diffused medium onto such hungry, newly emerging protocluster formations in the nodes, Fry explained. We are in the process of analyzing more observations on this and many other Planck protoclusters to try to trace the gas which gives birth to such newly emerging stars, as well as feeds the supermassive black holes, to ascertain its origin and also explain the identified extraordinary activity, Poletta said, referring to future research. Fry even displayed an excitement about the emerging data from the Large Binocular Telescope, which has views from NASA's James Webb Space Telescope, which has been launched on 25 December 2021. An experiment was conducted to develop conditions that replicate the galaxy clusters. Scientists undertook efforts to replicate the hot gas found in massive galaxy clusters, employing approximately 200 lasers. Earthbound research is simulating the tremendous heat observed in galaxy clusters in interstellar space. The experiment set is expected to disclose so much about the environment within massive galaxies. There, hydrogen gas could ignite at temperatures similar to those seen in the Sun's core, or around 18 million degrees Fahrenheit, which would round up to 10 million degrees Celsius. However, scientists are baffled about how these extreme temperatures may survive within clusters of galaxies, given that physicists' theories imply that gas should have cooled throughout the universe's existence of 13.77 billion years. As a result, a Lawrence Livermore National Laboratory in California team is researching these settings with the largest and most powerful laser facility, the National Ignition Facility. The parameters are established in a nickel-sized environment that lasts only a matter of seconds, but the team claims they are a suitable starting point for learning more about the galactic cluster environment. The University of Chicago, one of the collaborating institutions, said during a statement that the scientists concentrated 196 lasers on a single microscopic target, producing a white-hot plasma with powerful magnetic fields that endures for a few billionths of a second. This gave them ample time to say that the plasma had hot and cool regions rather than a uniform temperature. This is consistent with one of the current hypotheses for just how heat is retained inside galaxy clusters. According to the idea, heat is normally distributed when electrons, meaning charged particles, hit one another. The superheated gas, called the plasma, on the other hand, contains tangled magnetic fields inside a heated area. Instead of scattering their energy, those fields induce electrons to spiral in the same direction as the magnetic fields. Magnetic fields restrict energy conduction as well as dissipation by a factor of more than 100, according to researchers. In the same release, main author Gina Meinecker, a plasma physicist at the University of Oxford in the United Kingdom, remarked, "The tests are absolutely out of this world." Before using the facility, team members practiced their experiments to ensure they were prepared for the nanosecond scale operation with the lasers. The scientists wanted to implement precisely the correct measurements within such a short time frame because the tests in the lab were really a one-shot transaction. According to the scientists in a statement, whereas the new study adds to our understanding of how these galaxy clusters became so hot, there are even more unanswered questions. Though the cold and hot regions provide compelling evidence for the influence of magnetic fields on the cooling of hot gas in galaxy clusters, further research is needed to better comprehend what is going on. With the help of this experiment, we can know exactly what it is like to be inside a massive galaxy cluster. But what do you think is inside those large clusters? Maybe some alien sucking energy, or maybe God? Well, science has better answers and we'll stick to that. Anyway, that's it for the day, guys. If you are interested in seeing videos like this, then don't forget to hit the like button and let us know in the comments section whether you want to experience this at least once in your life or not. We'll see you in the next one. Until then, peace.